Welcome, everybody, to the American Space Museum. I'm Marquette. We're so glad you're with us to stay curious, kind of a spaced out stay curious with Terry White here, and something pretty interesting I have in the back.
Yes, it is. So it's if you don't realize it, it's a picture of our planet.
Yeah, stay curious a minute. Terry, great to see you.
Nice seeing you.
Well, once a month, Terry comes on Stay Curious and talks about his career as the Orbital Processing Facility Manager. We got, we'll tease that here just a second. I didn't put that picture up there. So thought I did. OPFs are the three garages around the VAB. And you spent an illustrious 30-year career or more since
Correct.
since 79, right?
78, yes, sir.
78 to
Yep.
the end of the program. And we love looking back on the perspective. Terry, you've been doing this for a year. What do you find that people are most fascinated about the space shuttle era?
They're just amazed at all the things that it accomplished and the fact that it had such a good success story. The International Space Station would not be there without the space shuttle, and we tended to service it for years. But out of the 135 flights that the space shuttles flew, 39 of them were constructing and maintaining the space station.
That's right. And a lot of them, the workhorse Discovery, OV-103 in the mix. The tail numbers, Orbital Vehicle 103, that's Discovery, right?
Correct. Yeah. So we tended to call them by their tail numbers.
Did you?
The rest of the world wants to call them by their names, but yes.
It can be confusing. 099, OV-099 is...
Yeah, well, it started out as STA 099.
Mm-hmm.
It was a structure test article, so it was never built to fly in space. After Rockwell built it, they turned it over to Lockheed, who did the shake, rattle, and roll test of it to make sure the vehicle would withstand the rigors of launch and to find out what needed to be improved when they were building the OV vehicles, which stands for orbiter vehicles. So after STS-1 and they looked at how much it cost to initially get the first one into space, then NASA wanted another one not near as expensive. So Challenger had to go through some additional work to get it ready, but then we turned around and turned it into a flight vehicle as well. So
the tail number of Challenger was
099,
09, and Columbia
was OV 102.
102.
And then Discovery OV-103,
Okay.
Atlantis OV-104, and Endeavour OV-105.
So everybody wants to know where's OV-100 and 101.
Well, 101 was a test article to prove that it's Enterprise, and
So that became Enterprise.
yes,
This was
yeah,
the,
it started out as
alt
Constellation, but the country at the time liked Star Trek, and so they
Mhm.
petitioned NASA to change it to Enterprise, which they did, and it did the landing test to prove that the vehicle could land once it returned from space.
OV-101.
Yep, and it was OV because it was supposed to become a flight vehicle, but it needed a lot more work than they said Challenger would need. So OV-101 never flew into space, but it is right now on a aircraft carrier in a harbor in New York City where
That's
people
right.
can go see it. Yeah,
That's right. On
Oh.
the Enterprise aircraft carrier.
correct.
And then 100 became a scrap, or what happened to that?
I don't know the history of 100. I never worked on it and that, so I don't know the history of that. I know they built the full-size model of the orbiter. The Columbus division of Rockwell was tasked with that job.
Well, we'll maybe do a whole show about this, but that was just a nice introduction to Terry. Become a great friend of our museum here. We love having you on with your expertise, and we got a great show today that's centered around orbital debris, and we're gonna set you up with how much orbital debris is out there, where some of it came from, why it's such a hazard, and Terry's going to show us where it was serious problems on the orbiters out there. So, but before we do that, Terry, we want to remind everybody that tomorrow we've got on our show Tom Jones, the astronaut, four-time astronaut, great guy, Mr. Tom Jones. We're a show we recorded Friday, And
He's a great author as well.
oh yeah, his popular book Skywalker, and he's got a new book, The Stories from the Space Shuttle.
Good.
He talks to at least one astronaut on all of the 135 shuttles and gets their reaction, something about that mission. And so Tom promised to do a book signing here at our American Space Museum. So you're going to
Good.
enjoy this conversation we had with Tom Jones last Friday, about an hour long. He thoroughly enjoyed it and walked around just bug-eyed in our museum here. He was really enjoyed it. And Nick Thomas will be with us a week from Monday. Our astronaut wrangler is going to talk about some of the shuttles of the month, and I'm sure he'll talk a little bit about GT11 launched yesterday in space history.
Okay.
Dick Gordon and best friend Pete Conrad
Okay.
flew in space in history 66 years ago yesterday. So look forward to Tom Jones tomorrow. Well, Terry, you know, we talk about the shuttles of the month, and though we're not going to talk about specific shuttles this month, did want to see if you had any comment about the fact that you launched 3 shuttles on the same day, or well, 3 years apart. All right, September 12th in 1991, STS-48 was launched. A year later, 47 was launched. And then in 1993, STS-51 was launched. Now, 48 was launched a whole year before 47. I mean, what happened there?
Well,
did someone get their math mixed up, or
No,
what's
they,
going
they
on?
had a numbering sequence and they were assigned a number, but then sometimes the payload wasn't ready. There were other issues that affected that. So flight, just because they were numbered, doesn't mean that 48 wasn't going to fly before 47.
Okay.
So yeah, there was various reasons as to why, but because of budget issues and that, once they assigned a number, it kept that number, even though it didn't necessarily launch when they first expected it.
As I get my shuttle scroll out here, it is such a mumbo jumbo, particularly the years from 2000 on, where different payloads and crews were jumbled around because of the need to get up now and do things there now.
And if a payload wasn't ready, we couldn't just stick another payload in because it took a lot of work for a particular payload. So once we started all the installation of all the supporting hardware for that payload, you couldn't just put another payload in there. So
I'm looking here, you had 86, 87 in 1997, then 89, then 90, and 88 was in between 95 and 96. Things like that going on. Look at that nice signature of Tom Jones there on on STS 80. And you know what STS 80 will with OV 102 will be forever remembered for?
No, go ahead.
The longest shuttle flight of all.
Oh, okay.
Yeah, that was 17 days almost, 80. That's the only question I'll give you today, Terry.
Okay.
That was Columbia's 21st mission. They were up there for 17 days almost, the longest mission on a, that was a spa and the Wakefield. It wasn't like a lab like you'd think kept them up there.
Yeah, usually the Space Hab or the Space Labs are the flights that kept them up there a long time.
And I love looking at the juxtaposition of space history. And Terry and I were talking about, as you see this chart, that at the bottom is the day of the month. So from the launch of STS-79, all right, on September 16th to the 18th, 3 days, there are 47 astronauts on 8 different orbiters, all right? Twice, 2 for Endeavour and 3 each for Atlantis and Discovery. And I just find that interesting that 47 astronauts can look up in the sky and say, I was orbiting this Earth on September 16th to 18th on there.
Yeah.
Oddly enough, Terry, there's no orbiters the first 6 days of the month. There's less than 3 weeks all year where there's no orbiters in history orbiting there. So a very busy September, particularly in the middle of September for you all. And I know you can't think back in time to, how busy it was, but what I'm always impressed with the energy was that going on out there. There was always something going on out there. It's not the case today. You
No.
know, there's some we've got a lot going on with SpaceX, soon Blue Origin, but as far as NASA, uh, there's a lot of hurry up and wait going on in my editorial for the day. So,
Yeah.
not I don't want to get you drawn into that. Here we are to talk about, but space history. We love it. We're the only ones on the internet that we think keep track of the shuttles, and it's all because of great people like Terry coming on here, willing to share their personal stories. And we're going to hear a few today about space debris. Is what we're going to talk about. Let me go this way. There we go, Selvin. Got Selvin Trotter on the board today. Marty took a day off. Selvin, thank you for pinch hitting today and setting stuff up. I got him out of the board meeting. He's grateful for that. That I set up. That's why we're a few minutes late. There's an artist's drawing of space debris. It's maybe not, you don't have jumbled trash like that. It's spread out maybe over a long time. That's when it blows up. All right. Terry, it's really become a problem. I'm going to use this info chart here for a minute. With the number of small satellites climbing and the number of space debris stories on the rise, what should we be looking at the most? All right. Well, I call your attention to the lower right-hand corner here, as I'll put it this way. Oh, you can't see behind me here. Lower right-hand corner says proportion of debris in Earth orbit. 42% of what's orbiting Earth are fragmented debris. Every nuts and bolts. And Terry's going to tell you what I couldn't believe is one of the most guilty things out there. Hold that thought, Terry. 22% of orbiting debris, almost a fourth of it, is non-functioning satellites.
Correct.
20% are mission-related objects, which means active satellites and other scientific things going on.
Things that are up there still doing their job.
Only 20% are of the debris. And then 17% are rocket bodies. And this is pretty scary because most rockets carrying satellites to orbit, the second stage is what went into orbit. People did not see Sputnik, though you'll argue with me you did. You saw the booster that put Sputnik up. It was way too small to reflect the light. But what the problem is, until recently, I mean in the last 10 years, none of these second stages dumped their propellants, leftover fuel. So we have up there generations of tattered, pressurized debris containing explosive fuel.
We even have nuclear up there.
We do.
Yes, the U.S. only launched one, but the Russian launched like 23 different satellites up there that had nuclear
power or warheads.
Yeah, nuclear, no warheads that I know of, nuclear power.
Mm-hmm.
Okay, and some of those, only one of them I know came down in Canada, but the others of them, as far as
I do remember that.
know, are still up there as you know. We're talking about space debris, but in reality, the majority of it, 80% of it, is space junk.
Yep.
Yeah, it's no longer functioning, or it is something that has come apart and released all its pieces up there.
Well, part of this meme here, and then I'll move away from it, but it emphasizes the altitudes we're going to show you here and how cluttered it is real quick, and then turn it over to Terry. The destruction of a Chinese weather satellite generated 3,000 pieces of debris. On February 3rd, a 20-year-old U.S. Air Force weather satellite just exploded. The propellant in it finally heated up right and blew up 50 new debris objects in there. The Russians, as smart as they were, they practiced their ICBM, intercontinental ballistic missile system, and blew up their own satellite, causing 1,500 pieces of debris.
Yeah, that was in November 15th of 2021.
2021, so we're coming up on 2 years ago. And what this talks about is the safest satellites up there are the little CubeSats. One, they don't have a big area to hit things. And two, they come down quicker in the space debris there. So what this all means is, here's a graphic showing you that if something is up in kilometers, all right, it's about a 1,000 kilometers is 60 miles. So something that is 1,000 kilometers, uh, uh, yeah, 100 kilometers is 60 miles. I'm sorry. It's a 6/10 kilometer per mile. So 1,000 kilometers is 600 miles up. And that satellite will stay up there for decades. But if it's just 200 feet, 200 miles lower in the 400 to 250 mile range, it'll only stay up there for decades unless it's boosted. And below 100 miles up, it'll just stay up for years. Now, these geosynchronous orbit satellites, the ones that stay over the Earth 22,000 miles up and broadcast lots and lots of our TV and radio and such, they stay up for thousands of years, all right? And we want to just remind you, as Terry's going to talk about some small things here, 25 millimeters per inch. And the impact areas we're going to show you on the shuttle are less than 1/16 to 1/8 of an inch, less than around 1 millimeter to under 3 millimeters. There's a couple big ones there. And then as far as kilometers, 100 kilometers is 62 miles. See that? 15 kilometers is about 10 miles. So you see, so now this is looking down on the Earth. The outer circle, Terry, is all of the geosynchronous satellites that are broadcasting from security things to sports around the world.
Global positioning satellites.
Yep.
Yep. So
Couldn't believe there's that many of them. Then you've got in between that's 22,000 mile above the Earth. So from one end to the other is 44,000 miles sphere. And the Earth in the center is covered with low Earth orbit, LEO they call it, satellites. That's where everybody, all these small companies like Viaspace.
there's so many,
going.
it makes the Earth look white. So.
Right. And then in between there are the Starlink satellites that over 40,000 of them have been authorized. Now this is that low Earth orbit from 100 miles to 500 miles. So it's quite congested. And here's what the problem is. These are actual pictures, Terry. You helped me find on the internet. The space transportation system on the left, number. And a lot of these are about a 1/16 of an inch across.
Correct. Yeah. So these are things that impacted the orbiter, things that we found when it got back. When they brought back parts of Hubble that they had replaced, they brought the old parts back with them, and they found impact holes in the Hubble's parts, their antennas and that as well. So these are things that we did. In the beginning, we thought we had to worry about micrometeorites. And then our detailed inspections of the orbiters when they came back, then we started picking up all of these pieces that were buried into the orbiter's TPS, into the tile, into the blankets, into the orbiter's radiators, which is its cooling function when it's in space. So all these things we had to go. We found them, and then engineers would give us a disposition to remove them. We'd route them out for them to analyze them and tell exactly what they were. Some of these are even caused by something as minor as a paint chip.
Yes.
So, but when the speed that the object is traveling and the speed that the orbiter would be traveling, when they come together, it could be catastrophic if it was something bigger.
I believe the one in the middle is a paint chip.
Yeah.
They could even tell the color of the paint that it hit.
Yep.
Because it's going so fast. This is, but there's some good news, Terry, that there's an International Orbital Debris Conference. And there is a NASA Association, division of NASA, that is now taking a serious study of this. They're having in Texas their second symposium this December. So I'll keep my eye on that and see what they do for y'all here on Stay Curious.
And not just the United States, but there's other countries that are really concerned about that. So there's a couple of countries that are doing a lot of investigation into potentially removing some of that debris from space. And again, space junk.
There have been some reports of satellites that just went offline. And they don't know, they think something hit them, and knocked their brains out or something like that.
The way they usually tell that is it used to be the U.S. Air Force, and now it's the Space Forces. They are tracking that, but they only track the larger items. They don't track the millions of detail small items, but they track the items are about the size of a softball up to the size of a school bus
Uh-huh.
that's up there. So
And you've got NORAD and independent ones to do it too. This is really astounding. On the left is a picture of the windshield of Challenger. All right. And on the right, that is a dish antenna on Hubble that something hit it and went through it. You actually see the Hubble silver kind of looks bluish because it's reflecting the Earth below, obviously, it looks like. But that went through it, Terry.
yes,
And that's a pretty big chunk of debris there. I
Correct.
mean, ouch.
Yeah.
So how did they build it? There's another uh, radiator imprint. That's over a half an inch, and didn't bring a shuttle in here with me. Duh, we should do that
yeah.
when you're on the show.
The radiators are the
but
coolant system
doors
inside the
open up.
payload bay
Yeah,
doors. Yes,
That's the silver part. If those don't open the first orbit, you have to come back, right?
correct. Yep.
In there, because you got to get rid of that heat.
Yep.
So
And people don't realize it, but the orbiter actually flies backwards in space to minimize impacts to the windows. You don't want an impact if you wind up hitting something, you don't want it to hit the windows or the crew modules. So
Okay.
they fly backwards. The engines have already served their function. They got you into orbit.
right.
So now if a piece of debris hits an engine, it's not going to be catastrophic as it could be of hitting the windshield.
Okay. I forgot about that, but that's right. Orbit into Earth in reverse.
Correct.
Okay. Here's an astronaut pointing at some orbital debris in space. Okay. How scary would that be to see a little crack? I remember driving up to Ohio not too long ago and getting a chip in the windshield. And of course, I would have drove with it for a while, but the lady I was with insisted we change that windshield there, so we did. NASA Orbital Debris Program Office. Who'd have thought that?
Yeah.
Huh?
Well,
They didn't think about that in 1960s, but we're glad we're thinking about it 60 years later.
Yep.
Because it's important. And this is what our screen is behind us here. This is a psychedelic look at close up through a microscope of one of these impact areas, which scientists can tell a lot from information like that,
Correct.
can't they?
yes.
Terry, tell me what they're learning. These are instances of windshield impacts.
Yeah. Well, they're like I said, they learn to fly backwards to minimize that, but it's just you can't hit the windshield. So I assume future spacecraft are not going to be built like the orbiter was, so they're not going to have a windshield to look out of that. They will have windows to look out, and that's a big concern of the debris hitting. And there were times that the astronauts had to reposition the orbiter while in flight. There's been times they've had to reposition space station. There's been several instances where they were concerned about a piece of debris could potentially impact space station that they had them get in their emergency escape capsule, the astronauts, just in case the item did impact. So, yeah.
And they basically 5 miles away. They're very, I mean, that's close.
Oh, did they get concerned
Yeah.
when it's further than 5 miles away?
And
So,
I wonder if there's like a mass attraction, like a magnet
I-
of some of this debris.
yeah, I've never heard that. But the debris is constantly changing position. Gravity is bringing that debris in, but it's also bringing in debris that was further out. So eventually the debris comes in and should burn up on re-entry, but there's been some very large pieces, one of them 480-pound piece.
Yes, you showed me a picture of
They
that.
came into Mongolia, and it surprised me that large of a piece made it all the
You
way
got that
to
picture handy there?
yeah, through
I'll show it up
re-entry, and it didn't destroy.
There's an impact, and I think people have seen little chips in their windshields and stuff like that. You can kind of imagine how something looks like that, and in your windshield going down the road, you know, you're wondering. There's what Terry was talking about there.
And you can see the U.S. Air Force is there removing or getting that piece of debris inside an aircraft to bring it back. But that thing weighed 480 pounds.
Wow. Yeah, that looks like a couch. Looks like somebody's couch they took off the street and getting rid of there. Yes, we'll do anything low tech, high tech, whatever it takes here on Stay Curious to tell the story. And this is a fascinating story. Was there any, and I didn't put a picture up of it, but do you all remember why Frank Rubio has set the record for the duration of, he's going to approach a year in space, and he's already broke Vanda High's record.
Okay.
But you know why this is happening, don't you?
No.
Because the Soyuz spacecraft that took him up there got hit by a micrometeorite, and it was outgassing ammonia fluids of its cooling system.
Okay.
They want to say it's a micrometeorite. Russia doesn't want to admit it could be a structural problem in the Soyuz, which
Yes.
is the world's most tried and true spaceship of all. So they did bring that back empty, and the reentry was fine. But to be prudent, they kept them up there, sent an empty one up there. That they don't want to bring it back right away because they want. So they said, we'll just keep you up there another 6 months. So that was the result of a micrometeorite impact.
6 more months without a shower.
That's right, without a shower. Frank Rubio is going to set the record. They're going to come back about no earlier than September 26th, I believe.
Okay.
So a couple weeks here. Here's a few, Terry, that I found that you're right, the internet's just full of things. There's more window impacts. Some of these are caused by paint chips, but a lot of them are caused by what? And I was fascinated that you said this.
By little bits of space junk. I mean, I didn't take them out of the windows, but I have witnessed big pieces of circuit board the size of a quarter or larger.
Board.
Yeah, and you could tell right away it was a circuit board embedded in the radiator and embedded in the tile. So in that case, we take the piece out, or if it's in a tile, we might remove the whole tile and send it out for analysis instead of just cutting around the piece to get it out. But and then rarely did they tell us exactly where it came from. In some cases they could tell, some cases they can't. But then we had to go do the repair. Just like an impact in a car, we still had to go up there and X-ray it and do dye pen and make sure we understood exactly what had happened to the vehicle. And then the mechanic would do a bond on it and repair it and replace that piece, or in the case of the tile, put a new tile in its place, and then back to work.
The here again is that looking at that. Here's the orbiter, a little schematic that or illustration we found. This is basically 100 orbiters from 6 to 110, and showing you lower surface impacts. Under an inch, and on the right side is bigger than an inch. Quite a few bigger. Now this is almost 100 orbiters, okay? Or is 100 orbiters.
Yeah, it's the data from over 100 flights.
But there's a definite pattern there.
Correct. Yeah.
And
now some of them
what did that show you going into the last third of the shuttle era?
Well, some of them, like on the left, there's a lot of them that are back after the main landing gear doors, so we knew we get a lot more impacts on landing when they used to land in the desert.
Oh, right.
Yeah, so they would land and it would kick up more impacts back there, and there's just other areas that systematically took more hits.
So you think that chart includes the landing debris impacts as well as the ET impacts?
That would include all of the impacts,
Okay.
Whether it was ascent, on orbit, or landing as well. When it got back to KSC, we documented every one of those impacts.
I find that very interesting. In many ways, one, a durability of the vehicle. It's not it had a lot of resilience to it.
It does. It was never designed to be impacted, but if it is, it did an excellent job of the thermal protection
So
system.
this was never
protecting.
accounted for in the 1970s when it was being developed.
No.
Huh.
No. Like I said, they worried about micrometeorites some, but they didn't worry about these types of things. And remember, back then, they didn't have a big understanding until STS-1 of the thermal protection system and what it could take. And it took us years to figure out what it could withstand. I mean, we had impacts knock a third of a tile out and it exposed the structure underneath. Yet the orbiter came back fine because the resultant material that was still left did an excellent job of absorbing the heat.
There's a few. Also, the wing tips, the RSS,
RCC.
RCC, yeah, RCC. which stands for,
reinforced carbon.
there you go. That's the dark leading edge of the wings.
And,
It's supposed to be tough as nails, and of course we know that it got busted into by a piece of foam off the ET on Columbia, but
yeah, and again, it wasn't designed to be impacted. The nose cone was also made out of reinforced carbon, but yeah, so we took impacts to them, but nothing as severe as the piece of foam that hit on 107. So
yeah, but pretty still all these about under a 1/16 of an inch. Selvin, we have a comment or question?
Got a question. Mark.
Yeah, punch your mic on there, Selvin.
All right. Ralph wants to know what is the protection against hull penetration from debris, and was there a procedure if the pressurized hull was penetrated while in space?
now that I don't know because I wasn't responsible for what went on in space of tracking that, but the vehicle did an excellent job. Like I said, it was never designed to be impacted, but it did an excellent job of protecting itself from these impacts. We never had one that violated the crew module, which is actually a capsule within the outer structure and that. But we never had one that there's a triple pane system to the forward windows, and we never had one that actually caused any type of leak on the window. We had to replace them because of an impact quite a few times. So
Quickly tell us about those windows. It's just not one window pane.
no, it's three different panes
with
and
the air in between them,
pressurized in between. Yes.
About how thickness between them.
The outer pane is extremely thick. So, and I never physically held an inner pane, so I don't know exactly how thick it was. But
I've actually seen a pat on the back awards to you space workers where they cut out a piece of the window and gave them as a memento.
yeah, they used to, certain things that we would take them out after a modification and would put something new in its place, that we did cut them up for mementos.
Yeah.
So
Yeah, I thought that was one of the neater memento things of it that I saw out there. Any other questions out there, Selvin? You're doing a great job. We're glad that Ralph's watching. We got all kinds of friends out there that enjoy Terry coming on every month, and we appreciate you scheduling it so we can advertise it some.
and I have a lot of family.
Oh, yes, you do.
That watches every one of the shows, and especially my grandchildren. But I want to do a wave to Riley because she waved at me on the last show, and I did not wave back at Miss Riley. So Grandpa's waving at you today.
Where's Riley at? I see you waving, Riley. All right. Good to Grandpa there, out there in TV land. Good for you there. Well, we know Travis is watching, and your daughter is watching, and wife, and we really appreciate you spending the time with us here, Terry. And you're a big promoter of our museum, and we appreciate that a lot. But why not? We feel like, like you do about this museum. It's one of a kind.
Yes. Yep.
And we really love talking about our space workers in the shuttle era. Wanted to transition from the shuttle to one of the important missions that the shuttle did that got delayed because of the Challenger accident and it couldn't come back. That was the Long Duration Exposure Facility, LDEF, in the vernacular of Terry White and his NASA chums. Tell us a little about that, Terry.
Well, LDEF was launched long before Space Station was built, but it was to test a bunch of different components, different metals, and that for the construction of the space station. So they wanted to put a payload up there that would expose these different panels to not only the potential impacts in space, but also the temperature ranges and the different things that a spacecraft gets exposed to. And the plan was to go back up and get LDEF after it was done and its flight and bring it back and then analyze all the different experiments. Well, it turns out we lost Challenger, so we didn't fly for a couple of years. So LDEF stayed up there a lot longer than it was originally planned, but they got some very good science off of LDEF. And when it came back, it came into the OPF-1, and we removed LDEF on second shift, which I was a second shift supervisor at the time. So yeah, I got to see LDEF when it first came back
Yeah.
and look at yeah.
Did it smell like space or anything? I mean, it's been.
Well, I don't think space
I
has
don't
a
know.
smell.
Did it have any smells to it?
But the payloads, they all had an odor to them. It's just like an aircraft, a military aircraft. You go into it, it has an odor, but nothing that jumps out and says, "Oh, well, that's a Hubble smell," or "That's
Right.
an LDEF
Okay.
smell." So yeah,
Well, I like the sights and sounds of things we can't convey visually. There's some impact incidences all around the LDEF. Uh, it's kind of like, the neighbor's going to paint their house, you're going to paint your house. You go to Sherwin-Williams and get 5 or 6 different samples and put them on your house for a month to see if they're going to fade in the sun
yeah.
or what it might look like under the weather or outdoor light. A lot of polymers, a lot of structural things up there. I mean, it looks like aluminum foil and things like that. Of course, it's not. I'd say this is material.
Yeah, it's a
for all
a
sort of
mylar
things.
film. Yeah,
For,
all different things that they had to sample. So
Of course, one of the bigger things they tested up there would have been the solar panel material
correct.
for its endurance.
Yeah.
And you say they brought solar panels back to look and inspect them.
Yeah.
Kathy Thornton threw the first set away on the Hubble up there, but some of them they keep, don't they? There's LDEF in space. I think that's when it was released. I couldn't find a good before and after. You think they'd find that same image and stick it there. I guess I'll have to do that. But nothing inside of it, right, Terry? It was all on the outside.
To my knowledge, but again, my job was the orbiter, not the payload, so I don't know what the inside of LDEF looked like. I just knew what the outside looked like, and then, we didn't have the ability to photograph any of it. NASA did, but once we got it out, it was put it in the container and send it out.
Shame on me for not doing my research, but I wonder where LDEF is right now.
I don't know.
Huh.
I never asked after the fact that we got to look at it, and that was it. So
Well, we're going to have Mikey Haddad on the last Wednesday of the month, the Level 4 payloads expert, and I'll ask Mikey about that, and I'll do that research because it's an important, I think it's one of the more underrated missions that's not talked about. They had to have learned a lot about it.
they did, because it contributed to the
Yeah.
construction of the
Out there.
space station.
So, Selvin, who we got watching today on Stay Curious?
We had Doug Forrest, Dave Stange, Lynn Feather, Gary Jeriel, Robert Law, Cynthia Rossi, Tom Uziak, Thomas Celentano, Chalked, Ralph, and William Whiting.
All right, guys. So thank you, ladies and gentlemen, for watching today. We're going to have an auction October 7th, Terry, and it has got some amazing things in it. These Robbins medals that are just offered to astronauts and flown in space, and all kinds of autograph things. We had our Chuck Jeffrey talking about it yesterday on Stay Curious. The first Snoopy given to Kingsley, who was a test astronaut at Grumman. It wasn't space flown, but it was the very first Snoopy
Silver
ever
Snoopy
awarded.
awarded.
In 1968. Chuck thinks it'll go for $10,000. So hang on to your Snoopy, buddy. Might be worth some money someday.
Remember, I have 2.
Oh, yeah, that's right. You do have 2. You got 2 how? Have to.
Well, one of them was, I was still working for Rockwell before the contract changed to Lockheed, but I got one when I was working for Rockwell for work I did on Columbia, and especially the work I did on Challenger. And then I got another one on when I worked for USA. So
Excellent. A double Snoopy guy here. All right. Well, I like that. You certainly deserve it. We're going to keep our eye on this international orbital conference that they're going to have in the first part of December. See what they come up with. I was telling you, I was talking to some old space guys, and they say, someone's going to come up with a catcher's mitt or something out there to catch all this.
That was one
or
of the
vacuum
proposals,
cleaner.
some type of net
Yeah.
that was forward of space station that's going around that collected that. impacts.
So somebody's working on it out there. One of the billionaires will clean up space. It needs to be, particularly with the Starlink system of Elon Musk, okayed for 10,000.
Yeah.
He's
Well,
got half of them up there,
well,
and another 40,000 could easily go up.
Yeah.
But what comes up must come down.
Well, in the early days, it was just abandoned in space. Once the satellite had done its job, it was abandoned in space. And then they realized, so to my knowledge, the plan is when you launch a satellite, you have to have a way to, at the end of its life, to bring it back into the atmosphere to burn up or to send it way out into deep space
Yes.
where it won't be coming back at us. So, but there's a lot of stuff up there that was not like that, or the things that got damaged that. But it's odd that some of the things they did in the early days. The U.S. military launched a system of copper needles, 480 million copper needles went to space. And what it was for, it was then we were communicating across the ocean by cable going under the ocean. Well, this was to create a reflector of all these copper needles up in space so they could communicate by bouncing off of these copper needles. And it worked for a while, but then the needles just started drifting away from each other and it didn't work anymore. But that put 480.
They're needle-sized needles, you think, or
They are about the diameter of a human hair, but still 480 million of them in 1963 is when they put those up. So
some unbelievable ideas like that
Yes.
that they didn't think it through the repercussions in the 21st century because we didn't know, and that's what the whole shuttle era was about, was testing the unknown of a space truck. That the legacy of it is criticized by some because we risked humans' lives to put satellites up, but on the other hand, we learned how to live in space,
correct.
learned how to repair reusable spacecraft,
Correct.
and I think
and repair satellites like Hubble.
yeah,
You know, so far as I know, there's no robotic system that can go out there and do the types of repairs that were needed on things like Hubble to make it continue to do the job that it's been doing for years. You know, so there are robotic ones they're working with to service. We have satellites that their batteries are no longer usable, so they have a robotic system, and we tested some of them with the space shuttle that the robot can go out there, open up a panel, remove the battery, put a new battery in place, and go. Some of them are go up there to refuel them. So
yeah, that was the big thing was having humans refuel.
Yeah.
Some of these up there. I think what is a great legacy of the shuttle era is that people from 24 countries got to fly in space.
correct.
With countries like the Netherlands and France and they don't have their own space programs.
No, I think Denmark was the
yeah.
Yeah.
And the fact that so many Europeans got to enjoy space,
Yes.
and that's a big legacy, I think, of the shuttle era that's not talked about enough.
Yeah.
Well, Terry, we'll figure out another part of this exciting legacy to talk about in the month of Rocktober.
Okay.
All right. Come up with something there. This was a great suggestion of yours there. Thank you, sir. Is there anything else you wanted to share with people out there about what's going on?
Nope. Just we appreciate your support.
We do. Selvin, great job today as we close our program today. And wanted to just remind everybody, we've got a great program tomorrow with Tom Jones. I really enjoyed talking to him. We had a lot of fun. And he dished out the ultimate compliment where he said that felt like a conversation.
Okay.
And that's what we strive here, not a bunch of rat-tat-tat questions for you to answer. And we're glad that you feel comfortable, Terry, helping us out here, sharing the wonderful world of the space shuttle era. Enjoy Tom Jones tomorrow. Until then, I'm Mark Marquette saying, I can't wait to see you to bridge the space between us.